Drilling hazard management is not only an operational discipline, it is a compliance discipline because hazards such as stuck pipe, lost circulation, borehole instability, and mobile formations can directly affect well integrity.
The focus here is the key message. Anticipate, control, monitor, and respond, so foreseeable drilling hazards remain manageable risks rather than uncontrolled well events.
Drilling hazards rarely occur in isolation. A pressure change can influence wellbore stability. Poor hole condition can increase torque and drag. Fluid losses can reduce hydrostatic pressure and create well control exposure. That is why the strongest regulatory view is not reactive. It asks whether the hazard was identified early, whether its consequence was assessed, and whether effective controls were in place before the event escalated.
So the question is broader than fixing the immediate problem.
Correct. The response must show a clear chain: hazard, consequence, control, monitoring, and action if the control is challenged.
Stuck pipe is a useful starting point because it can arise from several mechanisms. Differential sticking is one. Mechanical pack-off is another. Key seating and wellbore instability can also trap the string. The consequence is not limited to non-productive time. A stuck string can restrict circulation, complicate well control, require fishing operations, and affect the planned well trajectory.
That makes prevention a compliance issue?
Exactly. The operator should be able to demonstrate that the likely mechanism was considered. For example, differential sticking requires attention to pressure differential, filter cake quality, exposure time, and contact area. Mechanical pack-off requires attention to hole cleaning, cuttings loading, annular velocity, and drilling practices.
And if those conditions start changing, the control assumptions must be reviewed. Lost circulation brings the well control connection into sharper focus. When drilling fluid is lost into the formation, the hydrostatic pressure in the well can be reduced. That reduction matters because the drilling fluid is part of the primary barrier against formation influx. Losses can also damage formations, increase non-productive time, and complicate cementing or casing operations.
The response cannot be only add lost circulation material.
Correct. The cause must be understood. Losses into a permeable interval are not the same as losses into a natural fracture or an induced fracture. Each requires different controls. From a regulatory perspective, the operator must keep the well within a safe operating envelope. That means knowing the relationship between mud weight, equivalent circulating density, formation pressure, and fracture gradient.
So safe operating limits must be visible to the drilling team, not hidden in engineering assumptions. Borehole instability is the third major hazard. Weak, fractured, or reactive formations can lead to sloughing, caving, hole enlargement, or collapse. Those conditions can affect circulation, hole cleaning, casing installation, and well control. A poor quality hole also increases the chance that other hazards will occur.
The strongest approach is anticipatory.
Yes, geological information, offset well experience, drilling parameters, cuttings returns, torque and drag trends, flow checks, and real-time indicators all help identify instability before it becomes a major event. The compliance point is that monitoring must be meaningful. It should be connected to defined triggers and defined responses.
Monitoring without response criteria is not a complete control.
Mobile formations add another layer. Swelling shale, creeping intervals, or other mobile zones can progressively restrict the wellbore. The warning signs may include rising torque, increasing drag, poor hole condition, and difficulty running casing.
That is a gradual hazard, but it can still become a sudden operational constraint. These hazards support the central cycle: identify, control, monitor, and respond. Identification begins before drilling. It uses well planning, offset data, pressure prediction, formation pressure evaluation, fracture gradient assessment, hole geometry, casing depth selection, drilling fluid design, and drill string considerations.
Then the hazards must become controls.
Precisely. Controls may include mud weight selection, fluid properties, hole cleaning practices, casing setting depth, cementing strategy, stabilization, trip practices, flow monitoring, and contingency materials. But a control is only effective if it is suitable for the operation and if the drilling team knows when to act.
That brings competency into the control system.
Competency is central. Procedures, responsibilities, training, supervision, and communication all determine whether controls are applied correctly. A written control that is not understood at the rig floor is not reliable.
The operator also needs a documented well operation management plan, or WOMP, for relevant Victorian petroleum well activities. It must be appropriate to the nature and scale of the activity. That plan should make the compliance approach clear. The regulator should be able to see the connection from hazard identification through to monitoring and response.
Documentation is therefore evidence of control.
Exactly. It records what hazards were identified, what decisions were made, what controls were implemented, and how performance was monitored. It also supports review and continuous improvement. Environmental protection is part of the same framework. Lost fluids, uncontrolled flow, poor cement isolation, or compromised well integrity can affect people, assets, compliance, and the environment.
The objective is not to claim that drilling will never encounter a hazard.
The objective is to demonstrate that foreseeable hazards are systematically managed.
The essential message is clear: anticipate, control, monitor, and respond. Stuck pipe, lost circulation, borehole instability, and mobile formations must be treated as connected well integrity risks.
The open questions for any operation are direct. Are the hazards understood? Are the controls suitable? Are monitoring triggers defined? Are people competent to respond?
When those answers are documented and actively managed, drilling hazards remain controlled risks, protecting people, the environment, assets, and compliance.